What's up guys, this is Massey. Welcome to another video. In this video I want to talk about resolution of vectors into rectangular components. So what does that mean when we are talking about vector resolution? Vector resolution is a process where one vector is broken down into two or sometimes more smaller vectors. When we are talking about two vectors, usually it's going to be rectangular components. It means that we're going to break down the vector to two different vectors. One of them is horizontal vector, the other one is vertical vector. A vector can be resolved into two perpendicular vectors whose sum is the given vector. This is often done when, for example, both vertical and horizontal forces are acting on an object, and these are called the rectangular components of the force. For example, here we have v vector, and we can break it into horizontal component and vertical component. So vector v at an angle of theta to the horizontal, it can be resolved into rectangular components, which is vh as horizontal component and vv as vertical component, where v equals to vh plus vv. Find the rectangular components of a force. Let's see how to break this vector. A tow truck is pulling a car from a ditch. The tension in the cable is 15,000 Newton at an angle of 40 degrees to the horizontal. Draw a diagram showing the resolution of the force into its rectangular components. Determine the magnitudes of the horizontal and vertical components of the force. So we're going to have the force 15,000 Newton, and I'm going to draw horizontal and vertical forces. So how to find out? Based on this trigonometry and the definition of sine and cosine, we can say cosine 40 equals to adjacent divided by hypotenuse. So cosine 40 is going to be adjacent, which is horizontal force, divided by 15,000. So therefore we can say horizontal force is going to be equal to 15,000 times cosine 40. On the other hand, for vertical force, we can say sine 40 equals to opposite divided by hypotenuse. So sine 40 equals to vertical force divided by 15,000. So vertical force is going to be 15,000 times sine 40. So when you plug it there, horizontal force is going to be 11,490, and vertical force is going to be 9,642 Newton. Now for next example, find rectangular components that are not horizontal and vertical. A box weighing 140 Newton is resting on a ramp that is inclined at an angle of 20 degrees. Resolve their weight into rectangular components that keep the box at rest. So the box is being held at equilibrium by two rectangular components, which is force perpendicular to the ramp and force of friction, which is called F, lowercase f, parallel to the surface of the ramp. So I need to find the normal force, the normal vector and friction vector. So when we have it like that, we're going to say 140 times cosine 20 is going to be the normal, because n is going to be adjacent to 140. So 140 times cosine 20, this angle is going to be 20. And on the other hand, this force is going to be the vector like that. That's going to be 140 times sine 20. So when you multiply that, you see it in this slide, 140 times sine 20, that will be 47.9, and 140 times cosine 20 is going to be 131.6. So the box is kept at rest by force of 131.6 Newton perpendicular to the surface of the ramp, and by friction of 47.9 Newton parallel to the surface of the ramp. So let's summarize key concepts. Any vector can be resolved into its rectangular or perpendicular components. The given force F is the resultant of rectangular forces as horizontal and vertical forces. A horizontal component can be calculated by f times cosine theta, and the vertical component can be calculated by f times sine theta. It depends on the location of theta as well. So if you consider sine theta equals to opposite divided by hypotenuse and cosine theta equals to adjacent divided by hypotenuse, you can figure out what are the magnitude of vectors. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.